Here we go.
Okay, I guess it works. I hope you can see my screen. Thank you very much for coming. I hope you will enjoy. If you would have any questions throughout the presentation, the coding or whatever, just ask. We are a small group, so I guess it's quite easy to bring up if anything is unclear. So I would like to talk a bit about representing HTTP endpoints as data and then doing various things with this representation of HTTP endpoints, exposing them as a server, as documentation, clients, also a bit about serverless. So yes, let's start. So before we start, let's look what is the current state of art, right? How would you currently most often expose HTTP endpoints to the outside world? But if you are using Java, chances are quite high that you are actually using annotations, right? Maybe JE annotations, maybe Spring annotations, or some other form. But that is the most common, way of defining the metadata for an endpoint, right? So here we have a very simple example where we map. Where we specify that the method over here, it says service method, should be invoked whenever there's a GET request to the given path, and that we produce a JSON response, right? We have some parameters which are mapped over here. So the parameter from the path should be mapped to this method parameter. It's all quite readable. It usually works quite well. Admit, I guess, right? Okay. So why would we want, what would we want to improve here, and why would we want to improve it, right? Maybe not what's wrong with this approach, but let's look at what could we make better. Well, first of all, annotations. I have a long history with annotations, I guess spanning 10 years or more. It's kind of my hobby, you can say, in a way. So I've been a big fan of annotations. 10 years ago, they were adding type annotations, JSR 308, and so on. So I've been happy that I can put annotations everywhere. But then I slowly changed my approach. And well, if you really think about what annotations are, it turns out that they are kind of an embedded mini language that sits inside of Java, right? So we have the Java language with its own rules, with its own syntax, and then we have annotations, which are kind of an addition to what you have in Java. So you cannot really use normal Java with annotations, right? You cannot use the normal way of abstracting things. You cannot define a method which would produce some annotations or something like that, right? Also, the type system of annotations is much poorer than plain Java. We can only use primitives and nested annotations. We only get very limited time checking from the compiler. So this language, which is glued onto Java, is really quite basic. And what happens when the annotations are consumed, and how are they consumed? Well, they are usually consumed at runtime by some kind of a container. There are annotations that are handled at compile time, so let's leave them aside. But the most common form is that they are consumed at runtime and they are validated at runtime by the container. So what we are doing with the annotations, in fact, is we are programming the container, right? So these over here, these are instructions of what the container should actually do with these annotations. So we use this quite poor language of annotations to program our containers. Maybe it's a JE container, maybe it's a Spring container or some other. This container, again, only signals errors at runtime, right? So it will only tell you that you've got the wrong combination of annotations, or that these annotations don't make sense when you deploy the application, when you start your application, or maybe when the endpoint is invoked, right? Or maybe it won't do anything, it will just fail silently and things will not work. So I think these are some of the areas which we can improve. So we can try to use a more powerful language to define the metadata, not restrict ourselves to the simple language of annotations. We can try to push the verification from runtime to compile time. We can try to improve testability, And yeah, that I guess these are the main points. So so what we will try to do is we will try to describe our endpoints using a data structure. So here we will be using Scala as our host language. But my main goal here is though not to show Scala and not to teach you Scala or anything like that. My main goal here is to show an idea of how you can describe metadata, how you can express metadata in an alternative way, not using annotations, but using the host language. We will be using some Scala features which are unique to Scala in the particular library that we are going to use, but I think most of this can be reproduced in other languages as well. So once we have described our endpoints using a data structure, we will try to convert the data structure to a server, to documentation or a client. And yeah, we will see, well, you will be able to judge for yourself. How do you like it? How do you like the code? Can you understand the code? Can you understand the idea? And so on. So before jumping into the actual coding, just a brief introduction of who I actually am and why am I talking about these things. So I've been a backend developer for 14 years now. I started with J2E, then I had an episode with Jfokus, did some Spring, then I moved on to Scala doing Lift, then mostly HTTP, HTTP4S. I'm the co-founder and CTO at SoftwareMill. We are a company doing providing custom software in a variety of fields, a variety of industries, mostly backend systems, distributed systems, big data, machine learning, some blockchain, some messaging. We're also doing Scala Kafka customer consulting. And I'm also doing quite a lot of open source. That is my main focus right now. One of the libraries that we are going to use today is Tapir, which I'm developing, but there's also a couple of others. And we have quite a lot of interesting articles on our blog if you'd like to visit. Okay, so that's it for the introduction. Let's jump to the actual demo. So what we will be doing is we will be coding two simple endpoints which will manipulate a list of books. So we have a very simple database substitute. So we are not going to use a real database. We are going to use an in-memory database stored in a variable. Of course, you should never do it in production. It is thread unsafe. It is going to disappear once you switch off your code, your application. But for a demo, it should work just fine. Right, so here we have a list of books. That's like the initial state of the database. A case class in Scala is like a record in Java, so an immutable data structure, which you can easily create like over here. So yeah, so let's define our endpoints first. So we will be describing endpoints as code. So the first endpoint that we want to describe will be a post endpoint that should correspond to the book's add path. So we will create a value, an immutable value, which will describe our endpoint, and it will be called add book. So to start the description of our endpoint, we will start with an empty endpoint description, and it's so this value endpoint that I'm using over here. This comes from the tapir library, which we are using to describe our endpoints. An empty endpoint description doesn't have any requirements on the request, on the response. So an endpoint description in general maps some values from the request and maps some values from the response. So specifies what do we want to extract from the request and what do we want to write to the response when the endpoint is actually invoked. So we start with an empty one. It doesn't have any requirements, and we are going to use a builder-like interface to gradually specify more and more detail about the endpoint and impose new requirements of what our endpoint will actually do. So the first requirement is that on the input, so from the request, we require that the request corresponds to the books /add method. So here we specify the path with which the endpoint can be invoked. We also say that on the input, we want to have a JSON body, which should be deserialized to a book. And we will implement some security. So we say that we want to have a header, which should be deserialized as a string, which should be deserialized as a string, and the name of the header should be out token. Okay, so these are the inputs of our endpoint. So these are the things that we extract from the request. And one more thing, it should be a post endpoint. So we will specify it's a post endpoint over here. So each of these methods adds a new requirement on what the endpoint should read from the request. And it creates a new immutable representation of the endpoint, which we can further refine. So then we can specify what will be the output. So the output here, we don't do anything on the output. We don't return anything on the output. We will just return 200 OK, and that's it. But that can be an error. So if the authentication token is incorrect, we actually want to return an error. And in Tapir, actually, we specify separately the error outputs and the success outputs, because typically the shape of the data that you return in the case of error and in the case of success is really different. So in case of an error, we want to return a string body. Okay, and I guess that's it for the add book endpoint. Let's, in a similar way, define the list books endpoint. Again, we start with an empty endpoint. So this should be a get/books. We start with an empty endpoint. We say it's a get endpoint. On the input, we will implement some filters. So we want to filter by limit. We want to limit the results, and we want to filter by year of publishing. So we want to support these two parameters. So on the input, we want to accept a query parameter, which will be deserialized an optional int. So an optional int, it's a class which has two implementations, either none or some. It's very similar to an optional in Java. So the query parameter will be called year, the first one. The second will be called limit. And on the output, we will return a JSON body, which will be a list of strings. And in the case of an error, we return a string body. Okay, so we have described our endpoints. We now have two immutable values which hold the metadata about our endpoints. They describe the shape of the endpoints. So let's look at the type that is inferred for these two values. So let's infer the type. So you can see that the type of that value is an endpoint class. So let's look what that endpoint is. So we are going to go to definition. And the font is smaller for some reason. It is smaller. I have no idea why. But anyway, I hope you can see that it is, again, a case class. So what we have created is an immutable data structure. So the endpoint description that we have created are immutable data structures. I don't want to update plugins right now. And in that data structure, we have some inputs, some outputs. So again, let's see what an input is. So again, go to definition. An input is a sealed trait. A sealed trait is like an interface where all the implementations are enumerated in that source file. And there's multiple implementations. For example, we have, like, for each HTTP component you can have, there's an implementation. So we've got headers, we've got paths, where we can take a look at a query parameter, right? So a query parameter, again, an immutable case class, a record.
Adam, I think you need to make it larger. It's...
Yeah, but these are sources from a jar, and you know, here I have things. I have increased the font size.
Okay.
I have no idea why IntelliJ doesn't.
Command plus doesn't work.
No.
Oh, okay.
For some reason, when you are looking at the sources, it's smaller. But okay. it's the only place where I'll be showing library sources, so the rest should be good. So yeah, so we've got the query, which is also an immutable case class, and it captures the details of how that query parameter should be handled, right? We have the name, we have the codec, which is a way to deserialize and serialize the target type, some metadata like description examples, and so on. So that's the value that we have defined. It's of type endpoint, so data structure. Now let's take a look at the type parameters. The first type parameter describes the inputs. So what are we extracting from the request? And these, here we have a tuple. A tuple is a pair of values, so it has simply two values. And this corresponds to whatever we have specified in the inputs over here, right? So each input contributes some part of the input type. So post doesn't really contribute anything. It's a constant value, right? That we require the request to be a post request. Otherwise, the endpoint doesn't match. Same with a constant path. It doesn't contribute anything. We don't extract any data. That's just constant requirement. We extract a book and we extract a string header. And on the input, we get a tuple, which is a book and a string. Then we have the error outputs. So the error outputs correspond to whatever is here. So it's a single string. And in case of success, we just return a unit. A unit is a type with a single implementation, a single value, which is also called unit. So it's like nothing. It's a type saying that it's nothing interesting, right? Just some value. And this any, don't worry about it. It's like additional requirements that the endpoint has, like WebSocket support or streaming and so on. We are not going to use it here. In a similar way, we can look at the type of the second endpoint, and here we have a tuple of 2 optional integers. In case of success, we return a list of books, not a list of strings. And you can see that there's an error now in the type. So we have to actually fix the type annotation over here. So we have the inputs, error outputs, and success outputs in the type signature. So now let's actually use this type information to implement the logics, because what we have here are just descriptions of the endpoint's shape, but we cannot actually expose these endpoints yet because we don't know what to do when they are invoked, right? So to do that, we need to pair them with appropriate logic. So let's move to implementing the server. So we will first create an add book server endpoint. We take the add book endpoint and we couple it with server logic. So the server logic, as you can see here, the type or that type of the function that we need to pass in to that method corresponds to the description that we have created here. So it is all type safe. It is checked by the compiler. And here we need to take a tuple with a book and a string. So we take a book, and this will be the token. And what we have to return over here, let's take a look again at the type signature. We have to return an either is a type that can be one of 2 values. So it can be either a value on the left, which is a string, or a value on the right, which here is a unit. So it's one of 2 values. It's a general purpose type that is used to specify that we want to return one of 2 values. Typically on the left, you've got errors, on the right, you've got success. So here we need to return either an error represented as a string as described by the endpoint, or a unit representing success. And this can be wrapped in an effect wrapper. Typically this can be a future, for example. So usually you have some kind of asynchronous processing right now. So when you access the database, you actually get back a future. So we are going to pretend that we have such a thing, and we are just going to use a future, even though that we don't have to use a future. But because we are going to use later the akka a bit, so we need this future here as well. Okay, so we will now implement our business logic. If token isn't equal to secure, so that's the level of security we are implementing here. We return unauthorized access. Otherwise, we modify our database. So we modify a mutable variable, something you do very rarely in Scala, but sometimes you have to, especially on a demo. And we return a write, which is a success, right? So this is an instance of the either class, and this is an instance of the either class. These are 2 different implementations. Okay, this all type checked nicely. So let's implement list books server endpoint, list books server logic. Here, what we accept are 2 parameters, which are the filters. So the first one, let's see here, was the year, and the second is the limit, year limit. Again, we pretend that we are asynchronous. And what we are going to do is we are going to do filtered books. We are going to take the year and we are going to match. If the year is provided, we take the books. we filter them on the year equal to the provided value. Otherwise, we return the original list. Filter the books. Then we take limited books. So we take the limit. We match on the limit. If a limit is provided, we take the number of books that has been requested. Otherwise, we return all of them. And here, well, we don't really signal any errors ever. So we are going to always return a right filtered books. Okay, so now we have created, we have endpoint descriptions. They are coupled with a server logic that should be run when these endpoints are invoked. But we still need to somehow expose these endpoints to the outside world. So Tapir gives you an API to describe endpoints to capture the metadata, but it delegates all the hard work of actually binding the sockets, parsing the requests, and so on to some server implementation. And it integrates with many existing servers out there. So you can choose from Akka HTTP, HTTP4S, Vertex, Finatra, Play. I think that's it for now. So here we are going to use Akka HTTP. So what we are going to do is we have to translate these endpoint descriptions coupled with server logic into something that Akka HTTP actually understands. So what we are going to do is we are going to take the Akka HTTP Server Interpreter and we are going to call the toRoute method. So a route is the basic building block in Akka of defining HTTP routes. And we are going to provide the list of endpoints that we want to translate. So we take the first endpoint over here and the second one. Okay. Yeah, and that's it. And this function over here will actually translate the tapir representation to, oh, this should be limited books. That's why it's gray. It will translate the tapir representation into the Akka representation, which we can then use. So before actually checking if it works, we will do one more thing. So there's another kind of interpreter in Tapir as well, which translates the same endpoint descriptions into openapi documentation. In the descriptions, we capture all the detail necessary to generate these docs, to generate the openapi YAML, which can then be viewed using Swagger UI, for example. And that's what we are going to do. So we are going to take another interpreter, which is called the openapi interpreter, not surprisingly, openapi docs interpreter. To openapi, here we need to provide a list of endpoints, add book, list books. We could have used the same list as over here, not to duplicate, but yeah, so we are going to give a title, books I've read, version 1.0. Okay, so what we get here is a value of type openapi. Openapi again is a case class, so an immutable value, and it's a reification of the openapi model, which can be then serialized into a YAML or JSON. So we are going to serialize to YAML, and return a string. So the string we are returning here is the YAML with the docs. Okay, so now let's expose the server. So here we have a very basic Akka HTTP setup, right? So this HTTP comes from Akka HTTP. We are starting a new server at localhost 8080, and we are giving the routes which we want to expose. So the routes which we want to expose is first of all whatever we have created here, right? So here we have some tapir endpoints, which are then translated to Akka routes over here. So we take the value that is the result of this expression, and we also want to expose. The Swagger documentation. So we will expose the Swagger UI using the openapi YAML documentation, Swagger Akka.routes. Okay. Okay. So now when we call the start server method, we should have everything nicely exposed. So let's uncomment these two. So we are going to start the server and we will see if things actually compile. They will probably not compile, but we will see why in a second. Okay. Like mismatch, it probably needs some help inferencing the type of the effect that we are using here. Yes. So Scala can infer a lot of types, but sometimes you need to help out and say that actually the effect type that we're using here is a feature. So we started the server. So let's open the documentation. Okay. Now I can't see the address bar. Why can't I see the address bar? Okay, let's move it over here. And why does it expose the docs like this? It's something that I'm missing, and I think it's the path over here because I've created a catch-all and specified the path for that endpoint. So it was the first before the Swagger routes, so it was catching everything. So let's rerun it. Okay, so now let's see docs. Yes. Okay, we've got our Swagger UI. We've got our 2 endpoints. We can try, getting some books. So let's try getting 3 books. We got 3 books as a result. Maybe let's try adding a book with an incorrect authentication token. Hacker. Execute. And we had an unauthorized access as expected. So this seems to work. We have the documentation. We are hitting the server. So let's take a look at what else can we do with these. So that's like the basic setup, right? But what else does this representation actually give you in addition to what you can have with other approaches? So as an example of things you can do is you can extract some common code into a constant, right? It's a very basic refactoring, extracting common code into a constant. And some things here are repeated, right? We have the path prefix, for example, that is repeated. We have the fact that on error, we always return a string. So we can actually extract this into a common value. So we can have a value which is base endpoint maybe. And we say it's an endpoint where on the input we always require a book's path, and in case of an error we return a string body, right? So now we can use our base endpoint instead of the empty endpoint and actually remove all the duplicate information. So we are going to use this here. We already have specified the body, so we remove all of these redundant information. And now we have a slightly more compact representation of our endpoints. We don't have to repeat the same information over and over again. We can actually extract everything that is common to values. If you have a larger application, you can actually have a couple of base endpoints for various scenarios, maybe for various functionalities, depending on your use case, of course. Another thing that we might do is maybe we are in many endpoints to our system actually using the limit query parameter. So again, we can extract it. We can create a value which will be a limit parameter, and we assign it to that method over here, and we can use it instead in our endpoint. So the query method over here again returns an immutable description of a parameter that can be used multiple times in multiple endpoints. So these values again, they are immutable, so they are thread saved and can be used multiple times in many different contexts. And whatever is described by the limit parameter will be used, can be used in many endpoints. So we can, of course, refine our representation. We can, for example, map this to some value type so that we don't work with optional ints because that's not very readable. Maybe we want to create a custom limit type and map it to that. Maybe we want to add a description to that parameter and saying that's the limit parameter. That's a bad comment, but well. And then we have a reusable value, which we can use in many places. And another thing that we can do is we can add some examples or some metadata to our endpoints. So for example, here we can provide an example book. An example, again, this is well typed. It requires a book instance. So we say that as an example book, we will use Pride and Regardis, and it was published in year, everybody knows that, 1813. Okay, so we've got our example. We can describe our description. The token is secret. So you can add some metadata over here. I have no idea why this is red, but let's try actually rerunning it, and we'll see if it compiles. I've got EAP of IntelliJ, so maybe that's why. But it seems to have run correctly. And let's now see what's visible over here. Yeah, you can see that the documentation is actually over here now, right? We have an example value. So this is all nicely reflected in the documentation. Okay, cool. So what else can we do with such this representation of endpoints? Well, we can try actually going serverless. We have gone server full. In the example, we can try going serverless and writing another interpreter which will allow us to export these endpoints. So I won't write all the code because that's quite a bit more code, but I will quickly show you what are the general ideas. They are more or less the same. So let's switch projects to the tapir serverless project, which is like a proof of concept. So in this project, we have the same endpoints as we had before. So we have an endpoint to add the books. We have an endpoint to list books. We have the limit parameters, the year parameters, and so on. So these are that's exactly the same code as before. And this is here in the endpoints project, and it's a separate build module. You will see in a second why. So what we are going to try to do is we are going to try to export these endpoints using the AWS ecosystem. So let's go there. I have an image over here. So what we are going to do is we will take tapir and the tapir endpoint descriptions, and basing on these descriptions, we will try to generate configuration of the AWS API gateway. API gateway is a service with which you can terminate HTTP requests, and these HTTP requests are then translated into events. They can be SQS events, or for example, Lambda events, which we will be using here. So the API gateway will be sending events to AWS Lambda. So that's one way that we are going to use the endpoint descriptions, is to generate the documentation for the API gateway. The second way is we are going to actually couple, again, our endpoint descriptions with server logic. We are going to package it in a Docker container and publish it to a Docker registry. Here it's going to be the ECR Elastic Container Registry probably. And then we are going to deploy a Lambda which runs using this container, right? And it will use the same endpoints as described here. And then these events generated by API gateway will be used to invoke the appropriate endpoint from our Docker container. Okay, so we are going to use these endpoint descriptions in two ways. Okay, so let's see how it looks. Let's start the SVT console. So the first part is the template and the sum. What's the sum? Sum. So Amazon has something called the serverless application model. So it's an add-on on top of various Amazon services. It is a single YAML file where you can describe a configuration of your API gateway, of your Lambda functions, and a couple of other services, so that you can deploy it all in one go. You can apply it in one go, and it will appropriately create the endpoints, the Lambda functions, appropriately create permissions, and so on. So what we are going to do is we are going to generate, based on the endpoint descriptions, we are going to generate the sum YAML file, and then we will apply it onto Amazon. And that's the first interpreter that we have over here. So we have seen the HTTP interpreter, we have seen the openapi interpreter, and here we have the sum template interpreter. So it transforms these endpoints in a different way, right? So we have the two endpoints that we already know. We have our interpreter, and we can see we can actually run it, and we can see what's the output. And the output is a YAML file. I know everybody loves YAML files. So just a brief tour through that particular incarnation of YAML. We have the image URI, so this should be the address of the Docker container that we want to deploy as our Lambda function. So this will be substituted with the ECR address. We have some timeout for the Lambda function. We have memory size, of course. We are using Java, so we need at least 256 megabytes. And then we have the description of our two endpoints, right? That's the first endpoint, and that's the second endpoint, get books. And they are both mapped as HTTP APIs, which will invoke the Lambda function. And that's about it, right? So the file, the YAML file here isn't really very long, but still it's automatically generated, so that's nice. So that's the first component. So we will generate that template. What we need to give as an input to that template is the address of the container. So we have to create the container first, about that in a second. And then we have to apply it to Amazon. Okay, so now let's look at how the container looks like. So the container that we are going to build will be based on Amazon's Java base image. In the Java base image, we need to provide, we need to add our jar files, and we need to provide the name of the class that should be run when a request arrives to the Lambda. And that is implemented in the tapir handler. So this request stream handler, this one comes from Amazon, right? So that's the interface that we need to implement. And we need to implement the handle request method to actually handle Lambda requests. So what we do over here is, well, there's some, byte shuffling, deserializing, and so on. But in the end, what we do is we call the server, the AWS Server Interpreter. So that's yet another interpreter for our endpoints with the request and with the endpoints that we want to use. So the endpoints that we are using, again, the same, right? We are taking our add book and we are coupling it with the logic to add books to our in-memory database, exactly the same code. And here we've got the listing, which is exactly the same code as well, right? So we are again reusing the same descriptions to generate the AWS Server Interpreter. And well, it's some code which deserializes all the query parameters, the headers, the body, whatever the endpoint description requires, runs the logic and then writes the response. Okay, so now how to actually deploy all of that, right? So we have to build the Docker image, we have to generate and upload it, we have to generate the SAM file, and we have to apply it. So that's a couple of steps. You can do it manually, but here we have it automated using SBT. SBT is a build tool for Scala. Don't worry if you don't understand most of it. I will just show the most important parts. But while I'm speaking, I will actually run it. So we can see that it works. And here we have an empty repository. You can see that there are no containers. So we will actually upload a container and try deploying it as a Lambda. So I will run the deploy task right now, and then we will walk through what the deploy task actually does. So what we are doing, so here's the definition of the deploy task. What it does, the first thing is it publishes the Docker in the Lambda sub project. So let's actually go to the Lambda sub project. We go to definition, and here we have settings like the base image for our Docker, which is the Amazon base image. We have the name of the interface that should be run. That's the class, the app handler, and the tapir handler, which is extended by it, that we have seen, right? So this class is referenced over here, and yeah, and we have the repository to which we are going to upload things. So that's the configuration for the Docker image. And this SBT command over here, the publish in Docker in Lambda, what it does is it actually publishes things to the repository. So let's see. So this step should be actually done. If we go up over here in the logs, you can see that, yeah, this is already all published. So let's see. Yes, we have our image over here. It's 200 megabytes in size, but it's Java. So so the next thing we do is we actually run our some template interpreter class, giving it the URI of the image that we have just deployed and the name of the application. So we now have the YAM template, and when we have the YAM template, we now run the SUM tool. SUM is a command line tool that's provided by Amazon. It reads the credentials from the environment, so the secret code and so on, and deploys and applies the given SUM template to Amazon, creating, updating, removing resources as necessary. So here we give the repository again. We run it in a no confirm mode so that it's not interactive. And we can see in the console over here what happens. So let's scroll a bit up. Yeah, so these are all, these are all the resources that are created. So SUM uses CloudFormation, and it creates some roles, it creates some Lambda functions, as you can see, it creates some API gateway endpoints, and so on and so on. So a lot of stuff which you don't really want to create by hand. Okay, so now let's go to the Amazon console. Let's see, there were no functions 13 minutes ago. Now there should be a single function. Yes, there is our tapir serverless function. And you can see it has two API gateway endpoints attached. Same in the API gateway. Let's refresh that. There is our API gateway endpoints. Again, these two same endpoints. So let's try if it actually works. So we need to invoke these endpoints, right? Well, we could use Swagger, but we will use something a bit different. So what we will do is we will, let's just copy the address. So that's the address of the API that we have just deployed, the SoX J2DR5. So let's copy that. And what we will do is we will actually use yet another interpreter. So I have a client interpreter over here. So we are back in our project where we've been doing our coding. So yet another way in which you can interpret endpoints is as a client, because we've got all the information that's needed, right? So we have a client interpreter. So the client interpreter takes an endpoint. Here it will be the books listing, list books. The list books endpoint, right? So that's if we go to definition over here, that's the description of the endpoint which lists books. Only metadata. So we take the endpoint description, we provide it with the base address. So the base address here will be different. That's the one I have just copied from the other project, right? The SoX J2DR5. And we are going to call that endpoint using some data. So again, this is fully type safe. If we look at the type hint over here, we have to provide two optional ints. The first being the limit, the second being the year. Or did I get it right? The first being the year, the second being the limit. So we are probably want to have none as the first one and sum of 3 as the second one. So again, probably would be useful to have some value types over here to actually, have a proper limit filter type and a year filter type. But again, the fact that we are providing the proper types of parameters over here is compile time checked, and we can run it and we can run the request. Okay, so now let's try actually running the client request. So let's stop our server and we run it only with the client request, and we will see what happens. Hopefully something will happen. And it's invoking, and suspense is increasing, and we have a result, right? So we have 3 books from our, this time we have invoked the Lambda function. Well, we have hit the API gateway, which invoked the Lambda function, which then returned the response. And we can try it with 2. So now the response should be significantly faster. So the reason why the initial response was so slow is the cold start problem of Lambdas, right? So when we just create a Lambda, it's not deployed anywhere. There's not an instance, there's no server running our Docker container and serving requests. So this is all managed by Amazon, but it is started on demand. So when we first invoke our endpoint, Amazon has actually to start an instance of our Lambda. It will keep it around for like a couple of minutes before killing it, unless there are new requests. But still, as you have seen, the size of the image here is 200 megabytes, right? So it needs to be downloaded by Amazon, and the Java needs to be started. So it takes a couple of seconds. So the time between the first request and the first response is typically like 5-10 seconds, something like this. Later, it's all fast and nice, but the cold start is a problem. One way to solve it is to use Graal. So Graal VM has a tool called native image, and here there's a sub project allowing us to actually deploy and build a native image with these endpoints. So what native image does is it takes a bunch of jar files, it takes the entry point, and it analyzes which classes are actually used, and it only retains these classes. Then it generates a native binary, which has, it's not a JVM, it has a garbage collector built in and everything, but it doesn't, it's not like a full JVM that you can actually run code on. So most of these dynamic capabilities of the JVM are not available. But it is a small native binary that you can run, and it starts up in a matter of milliseconds instead of a matter of seconds as in Java. So it sounds great. There are some downsides. So the downsides is that actually building a native image, so invoking the native image tool and generating, analyzing which classes should be retained and which should not, this takes a long time. So it's like a minute, 2 minutes, sometimes 10 minutes for bigger projects. So that is considerable. That's a considerable amount of time. And if you have to debug, and you often have to debug Graal configuration, it's a very low it's very bad feedback time. And why do you need to debug Graal configuration? Because all usages of reflection need to be either explicitly flagged or otherwise won't work. This mostly isn't a problem in Scala, because Scala libraries use very little reflection, but still in Scala we very often use Java libraries, for example, for logging or for stuff like that. And even logback uses reflection, so it needs to be properly configured. So there is some, yes, I'm in the build file. So there is some Graal configuration that you can see over here. So there are some flags which you just need, otherwise things won't work. And I haven't really investigated why it's like that. There's some unsafe utils which you need to provide to Graal so that unsafe actually works. And there's some magic that you need to do. It takes some time to get it right. So after the initial effort in actually building this configuration and debugging it, which takes time, you get a very nice binary, a very nice small binary which runs very fast. So as you can see here, as the base image for our Graal version, we are going to use Alpine Linux, which is a very small image. We are not going to use the Amazon one, which is the base Java Amazon image is like 150 megs or even more. Alpine is much smaller. And yeah, I'm not going to build it here because, as I said, it takes like 1 or 2 minutes. It's not the most interesting, but I have one deployed over here. You can see that it's the same code exactly as we have seen before. It's just compiled using native image, and the Docker container that's deployed over here contains Alpine Linux and the native image that we have built. But you can see that it's much smaller. So it's 12 megabytes comparing to 200 megabytes over here. And it starts in a couple of milliseconds. Yeah.
I think it's time to wrap up a bit. It was a lot of stuff.
Oh, yeah,
I guess
sure.
A lot of people have questions. So we believe you that the
it is the last thing I wanted to say. Yeah. Sorry. Literally. Okay. So yeah, okay. If there are questions, let's go to the questions. Then I have a short summary over here, but it's nothing new. So yeah, what we have seen is we have seen how to describe HTTP endpoints in a type-safe way. How tapir gives you, I hope, nice and readable syntax. I think that even if you don't know Scala, if you don't know tapir, if you see a value like this, right, where you have base endpoint.get .enquery and so on, you kind of probably will get the idea of what does it mean. So I hope at least that it's at least a bit readable, and that we have retained the readability of the annotation approach, but we have also extended it by the allowing abstraction, by allowing multiple interpreters. And the general technique here is to separate the description of something that we want to work with from its interpretation. This gives us a lot of freedom in which we can manipulate things. So I will be happy to take questions. All of the code is available on GitHub. Tapir is an open source project. Please take a look. If you're interested in Scala, we have a weekly newsletter, so you can subscribe there. If you would have questions later on, my DMs on Twitter are open as well.
Thank you very much, Adam. That was great speed. A lot of material covered. I'll switch off the recording now. So and people, please ask your questions if you have any.